Hi, this is David. Welcome to Part 1, Topic 2, John Hall, Chapter 22 on estimating volatility. The associated workbook is T2.11.22 Volatility. It's labeled this way because it's Topic 2 in the Part 1 FRM. The dot 11 indicates reading 11 in the Part 1 FRM, and 22 because it's Chapter 22 of John Hall's 8th edition. That's the 8th edition of his book, Options, Futures, and Other Derivatives. Now, the workbook contains several worksheets. The first one is designated as highly relevant if you're using the worksheets, and that's a practice sheet for exponentially weighted moving average, GARCH, and the GARCH forecast. 1122 is a little more detail with actual historical, that uses a historical time series to show you what the comparison would be, the output, moving average versus the exponentially weighted moving average and GARCH. 1122 is GARCH 1 simulation. And then finally, an example of fitting the GARCH parameters with the maximum likelihood estimate method. That would be low relevance for the exam. And again, as I mentioned, this is 8th edition of John Hall, although I will tell you that since the last two editions, this assignment, estimating volatilities, although the chapter numbers changed, it used to be chapter 19, very little difference. If you're using this, even if you're using the 6th edition of John Hall, it would be just as relevant. This chapter has basically not updated in several years. And that's not a criticism. That's just because these volatility approaches here are so basic that they haven't required any updating. But we start here with a discussion of how historical data and various weighting schemes can be used to estimate volatility. So we're really in the realm here not of implied volatility, right? Where implied volatility would be where we use a traded price to infer what the market is telling us about in volatility. This is the other approach. This is where we use a historical series of returns to compute a historical volatility. And at the top here is our most basic approach. And in Linda Allen, Linda Allen refers to this as the standard deviation approach because the square root of this would just be the standard deviation of the return series, albeit with some simplifying assumptions. But here we're just taking really each of the historical returns in the series. So in John Hall, each of these U's denotes a daily return, right? We could have other periods, but most often we're dealing with daily returns. And we're making two simplified assumptions. First, we're assuming the conditional mean is 0, and we're going to, instead of an unbiased estimate of variance, we're going to compute a different estimator. So we're not using m-1 or n-1, we're just using m, the denominator. So it's a simple average. So it's a little simpler here, but all we're doing is taking the series of daily returns